Hello class, and welcome to section 10.5. We're going to spend the next 3 days on section 10.5. The first part we're going to cover the distance formula, so this is what's going to be covered in the first video. The next one will be a particular application of the distance formula, and then that last video will be the midpoint formula. So the next 3 videos are going to cover section 10.5. The distance formula is an equation that allows you to find the distance between 2 points. So it lets you find this diagonal piece. If you notice, when you're finding that diagonal, your 2 points actually form the hypotenuse of a right triangle. So if you take the straight line, that's your hypotenuse, or you can take the leg and the leg to take the less direct route. With that being said then, to get from here to here, if you were going the long way, you would be taking the second x value and taking off the first x value. So let's say that this was 7 and this was 4. That distance then would be 3. So that's that first leg, is taking your second x value and taking off your first x value. Looking at this height part then of our right triangle, that would be the second y value minus the first y value. So taking how far up and then subtracting the initial point for how far up. So why is this important? Those build our pieces of the distance formula. So to find the distance between 2 points, the distance is equal to the square root of the second x minus the first x squared, so my first leg squared, plus the second y minus the first y squared. So that's second leg squared. So a squared plus b squared, and then normally it would be d squared, but we don't want the distance squared, so we take the square root. I realize this looks like a pretty complicated formula right now, but when we actually start using it, it is very straightforward. So if we're finding the distance between point A, which is at -2, 1, and point B, which is at 4, 3, we're going to use that distance formula, which I'm going to write here just quickly for your reference. So again, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the first thing you're going to want to do is label your points. So we've got the first x is x1 and the first y is y1. And then we've got the second x is x2 and the second y is y2. So we're going to plug in that information and say distance is equal to the square root of that second x value, which in this case is 4, x2, subtract x1, which is -2, and then squared, plus y2, which is 3, minus y1, which is 1, and squaring that. Now, we all know from that first part that a negative minus a negative is a positive. So we have 6 plus 2, and then to the second power, 4 plus 2, which is 6, to the second power, which is 36. So we got the square root of 36 plus, and then we've got 3 minus 1, which is going to be 2, to the second power, which is 4. So then our distance is going to equal the square root of 40. When you type that into your calculator, you are going to get an answer with rounding of 6.3. So we're just going to round to a single decimal place here. So the answer is going to be a distance of 6.3. Go ahead and try this one on your own. Again, if you were going to label your points, you would have x1, y1, x2, y2. Plug that information into your formula, and you're going to get a distance of exactly 13 between those 2 points. Again, you can do this on a graph. So if these points are given to you on a graph, you're going to have to choose which one is your first and which one is your second. So I'm just going to say this is x1, y1, and x2, y2. So I'm going to say my distance is equal to the square root of x2, which is 7, minus x1, which is negative 2 squared, and then plus my y2, which is negative 4, minus y1, which is 8 squared. Again, we have a double negative equals a positive situation. So I've got my distance is equal to the square root of 7 plus 2 is 9. 9 to the second power is 81. Plus negative 4 minus 8 is negative 12. To the second power is positive 144, because negative 12 times negative 12 is positive 144. Then when you add those together, 81 plus 144 gives you a square root of 225, meaning that your distance, when we type that into the calculator, is going to be 15. So again, y2 minus y1 squared plus x2, or plus parentheses y2 minus y1 squared. Go ahead and try this one on your own. When I did this, labeling my points, I picked this as x2 and y2, and up top x1 and y1, plugging it in, and you end up with an answer of 12.7. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.